Co-function identities. Okay, what is a co-function identity? Well, let's write one down for an example. Sine of pi over 2 minus x equals cosine of x. You guys got that? Okay. Now, what would that look like if I wasn't in radians? Sine of 90 degrees minus x equals cosine of x. Okay, and I'd say 90 degrees. I'm going to degrees now because of this. These are in degrees. Now this says, use the cofunction identities to evaluate the expression without the aid of a calculator. All right, so at first I glanced at this and I saw cosine. I thought maybe this was sine and this would just equal 1. But that wouldn't be true because these angles are different. And it's also not true because that's cosine. I'm sorry, was that confusing? Okay, so this says evaluate this. Okay, so if I square both sides, that would be the same thing, the same identity. Are you guys okay with this? If I square both sides, it's still a cofunction identity. All right, so what is 90 minus 55? 35. Okay, so actually, I can write this differently. Man, this was kind of confusing me for a second. Now you can go two different ways. I'm going to go cosine squared 55 degrees, and I'm going to change that's 35. I'm going to change this 35. Well, actually, it's still going to be 35. I'm just going to change the way he looks. I'm going to say 90 minus 55. You guys okay with that? Okay, so
You mean sine?
No, I don't, because this minus this is 35, right? So I just wrote the same thing as this, but I wrote it differently. So using a cofunction identity, this would be your x, right? Okay, so that means I can rewrite this as sine squared of 55 degrees. Because if I had cosine 90 degrees minus x, what would you say this equals? What would you say that equals? Sine x, right? Those equal each other. So the x in our case is 55. Okay, so now what does that equal? Come on, you guys know this identity. Sine squared x plus cosine squared x, no matter what x is, equals
1.
Pretty? No, not pretty?